Hello there. Today we have Eden Marco on the podcast. Eden, we're so excited to, have you in the podcast with your background as a Google customer engineer, especially working on Gemini and LLMs at Google. I'm really, really excited to get conversation. So the first question is, Eden, can you tell us a little bit more about your background and your work with LLMs and AI?
First of all, super happy to be here, Vivek. Thank you so much for the invitation. I come from a software background, was a software engineer for many years, mostly in cybersecurity companies, specializing in cybersecurity, cloud security. And in since the inception of ChatGPT, LLMs, I was very interested and curious about this topic. And I've been a very big advocate of the entire ecosystem, especially open source, since then. So basically, yeah, you have two types of people going into the Gen AI world as far as building the products featuring Gen AI features with LLMs. So you have
Mm,
from the one side software engineers, which are going towards data science. And from
mm,
the other side, you have data scientists going into software engineering, right? So I come from the software engineering side.
awesome. So, Eden, let's go into Gen AI. If you can contrast Gen AI from traditional AI or machine learning, how is it different and why is it exciting?
So I think usually in general, machine learning, classical machine learning, is that when you
Mm-hmm.
have a problem that you want the machine learning model maybe to classify something or maybe to give
Mm,
a score between a 0 and 1, like
mm,
a
mm,
probability, maybe a confidence score, etc.
mm, mm,
And in the past, dealing and working with machine learning and artificial intelligence, you would need to have a lot of background. You would need to have maybe a master's degree. You would need to work
mm,
in as an ML engineer, and the barrier of entry was very, very high, right? So 21, 22, I don't remember when a chat GPT came out. So it introduced the concept of generative AI.
mm,
In generative AI, the model, what it actually does is generate text, maybe generate also images or audio, depending what model you're using, but it's
mm,
generating content for you. Now, what it's generating is usually a paragraph, maybe a couple of paragraphs when we're talking about text. This is a very common use case.
mm,
And the results that you get, maybe a song that it is writing, maybe summarizing some text, the result that
mm.
you get is not a result between 0 or 1 or yes or no. It's real content that you can use, right? So I think this is the main difference. And what it did actually, it remember that barrier that I told you that you need to maybe have a master's degree or a PhD. So
Mm.
once it came out, it really removed this barrier, and since then right from the beginning, people without this knowledge could actually use, right? A lot of people can get tons of value from apps like ChatGPT or the chat of Mistral, and you can get a lot of value from that. And what it actually evolved now, and when you're talking in April 2025, so maybe at the beginning, the early adapters were like very techy. They were like maybe people with a coding experience and trying to leverage it to really build things, right? But what we're seeing right now, a lot of companies are doing very well. Companies like Cursor, like Windsurf, like Lovable, companies like Base 44 and Ball.new, which help people with the help of generative AI, build products. So now anyone with those kinds of products, because they have those AI agents working together in order to build something and to generate code. Yeah, so I say that in generative AI is generating text. So those companies are actually generating code that is very, very, which is deployable, and people are building amazing things with this vibe coding concept where they simply prompt, the AI spits out all the code and it does it very well. And you have lots of people without any coding skills building really cool stuff.
Awesome. So Eden, so generative AI is accessible to anybody. I don't need a master's degree in AI. I can simply go ask ChatGPT to create image, text, code, but then also as a product manager or a product engineer, I can now go use the API, go to the OpenAI playground and use it to build products, also build AI powered products. So what I want to do is I want to double click on what are LLMs outside of just, using ChatGPT, like how do they work and how do they help you build products?
Right. So it's a very big question. I'll try to break it down piece by piece. So first of all, let's talk about how LLMs work underneath the hood. So underneath LLMs are large language models, are AI models, which are trained on a very large amount of data. Basically, what all those companies do, they have a lot of data, whether they're scraping the entire internet, and they train the model on that. And what actually the model itself, it may look like magic, right? So like when you ask it to write a poem or to summarize something, and you get very very good results, and it looks like, whoa, this is like somebody is real. But in fact, it's very simple how it's working. And in fact, what it does, according to your prompt, the model, what it's doing, it's guessing word after word, token after token. Usually you can refer to a token as a word or as a part of a word, but it's guessing one token and one word, one after another. And the cool thing about it is that every time it guesses, it also uses the tokens previously that it guessed. And this helps to calibrate the model. So the fact we get this very cool answer, but it's actually all statistics. It's all taking what's the highest token and what's the highest probability for this token to appear here. And that's why, by the way, when you're first seeing in the interface of ChatGPT or other applications, you see it's like streaming one word after another, because this is what's actually happening with the model. So, and this actually, by the way, maybe we'll talk about it more. It brings the concept of prompt engineering. So prompt engineering, the art of getting from the LLM to do what you want and to optimize results. So in fact, when we prompt engineer, we actually change this probability pool that the LLM is using, and we're actually scoping down those specific tokens. For example, if I'm prompting for something financial, right? So maybe it's going to give more priority to tokens like stocks, like, I don't know, like a bear market, bullish market, etc. So this is it's very cool to see it. And getting back to your original question about product managers, so there are a lot of things and a lot of use cases where product managers can use it and can leverage it. First of all, for productivity, and that's for writing emails and for doing all the things that maybe people are aware of, like maybe summarizing meetings and creating things. We are seeing a trend right now of, remember when I told you earlier that I come from software going into AI? So now we're seeing, usually there is a distinction between product and R&D, right? For people from the engineers who write the code. So what's actually I'm seeing right now, those product managers that most of them did not code. What I'm seeing right now, those product managers right now with all those AI powered tools can code, vibe code. Let's put this in double quotes. And we're seeing them building very cool things and building prototypes, right? I'll give you very, very recent use case I've heard about. So there is an integration between Figma. You familiar with Figma?
Yep.
Into Cursor. So basically they can simply take Figma design and they can turn it into code, and they can play with it and they can move the buttons around. And this is something, for example, this is a use case where they would need to talk to a front-end engineer. Hey, can you move this button here? Or can you make this pattern a bit larger? And this is not the case anymore. They can do it themselves, and they can run a lot of A/B testing. So this is from the AI coding side. And the other side is building for their company's products that their customers will use, powered by AI. And we're seeing almost every company right now wants to have AI, and there is a product manager behind it, adding to this SaaS service, software as a service, AI features.
Awesome. Eden, so we're going to go a little bit more into prompt engineering and advanced prompting. So if we are trying to use product AI for as a product manager, so there's this concept called RAG. So to get better answers, like, first, if you can explain what is a RAG and retrieval augmented generation, and how does it work, and how do you use that into, like, give us an example.
Sure. So let's start with REG, and let's start about what REG is solving. So LLMs by themselves, they're trained on data, that all the internet data, which is very nice, but this training happens earlier in the past. So each model we are using, there is this cutoff date that the model knows everything it knows up until that date. So it's not something that is changing in real time. So let's say we're using a model that was trained on the beginning of January 2025. Everything after that, it doesn't know. Okay, so there is this recency problem. So problem to get real time information, the model can say. And in those kind of cases, if you try to ask for questions like real world, like what's the weather right now, or who is how much, or what was the result of the match yesterday, whatever, the model in the worst case will hallucinate and generate nonsense. In the best case, which is happening right now, it would say that it doesn't have access to real-time data because it's not connected to the internet or something. Okay, so this is one problem. The second problem is that it's not a problem. It's not a problem in the design, but it's the second problem. It's not a problem, but it's a part of the design. The fact that those LLMs are trained on large volumes of data, they're not trained on your proprietary data. So, for example, your own documents, your company internal data, maybe you have databases, maybe you have internal documents, it doesn't recognize them. So if I want to use LLMs in order to interact and to consume this knowledge and to help me, for example, ask questions on my proprietary FAQ page for internal employees, it cannot do that. Okay, so regs comes to solve those two problems. So basically in RAG, like you said earlier, it's retrieval augmented generation. What we do is a technique. It's actually, there is a part of prompt engineering because you can also tweak the prompt a bit, but in general, it's a technique where we mitigate over those two problems. And what we do there, we first retrieve. Okay, so for example, we ask the AI a question like something about our own internal documents. And what happens in the background, the AI system fetches the relevant data, right? So the relevant data, for example, I'm asking about document X. So it fetches document X or part of it which is relevant. It then attaches it to the prompt. So my original question was, for example, how do I do Y in my company? And Y is something very secret, which is described in a document X. So what happens there, the AI system fetches this document X, and then instead of asking your question as a standalone, how do I do Y? It asks, how do I do Y? Here is document X, which is going to help you explain that. And when you send that to the LLM has no problem of spitting out the answer because you basically ask the question and you tell it where to take the answer from. You ground your answer in that document. Okay, so this is the retrieval. The augmented is augmenting the original prompt. So the original prompt was augmented with the context. Okay, so with the relevant context, and the generation is the regular generation. So this is what we're sending to the LLM. Okay, so this can be internal documents. It can be databases which are internal. It can be maybe searching the internet. This is kind of a RAG form because you fetch relevant information real time. You
Hmm.
attach it to the prompt. So I still consider it as a part of RAG.
Got you, got you. So Eden, I want to make this real. So you and I both are course content creators, right?
Yes.
And let's say if we want to build like an intelligent chatbot and we wanted to train this chatbot on all of our, regular base model, and then we wanted to say, hey, when you're answering, also refer to the transcript of the course and give them where these concepts are really, we have examples and we've done a deep dive, right? Or if you wanted to make the tutor even better and we're using the RAG, can you share with us on how and how else we might implement RAG for an intelligent tutor?
For what?
For an Intel AI tutor that we create, a
Yeah, so what
chatbot.
you described is actually the correct flow. So you would need to first to give it the sources that you want to augment your original prompt. So you need to give it like your data, which the LLM is probably not trained on your the transcript on your videos. So this data might be maybe proprietary, but not exposed widely in the internet.
Yep.
So you would use this data, and then every question that somebody asks, it would search in that data. There are techniques to do that. We'll not dive deep into them now, but it would fetch the relevant information from your transcripts and then attach it to the original question, and that would be eventually sent to the large language model. Okay,
Mm.
so it's often referred to, by the way, as in context learning.
Mm.
So you're not really taking the model and fine tuning it and doing anything. It's simply a very smart way to add to your prompt the right information, which is going to help the LLM answer it.
Awesome. Okay. So here we're also introducing let's say we want to take this chatbot to the next level and we want to add some agentic features, right? Like help us understand what are agents and in this context, how might we use an AI agent?
So agents, there are. If you ask 10 people what are agents, you'll get ten
Yeah.
different answers. But they all share a similar concept. So an agentic system is a system where you have an LLM making decisions what to do and which flow to execute, right? So and this is the agentic part, because we have a regular software where we have code, and the code is very precise. We know exactly what's going to happen at every step. So this is very deterministic. LLMs, on the other hand, they're not deterministic. They're statistical creatures. So once you embed an LLM with code, and the LLM decides where to branch out and maybe to execute this or to execute that or to do this or to do that. So this is the agentic part, right?
Mm.
So when you integrate into those flows an LLM, so it's a decision maker. It's not right now. It's not only generating the content. Okay, it's
Mm.
not only generating the answers like we did in RAG, but it also making decisions in that system. And if I'll take the example of RAG, so there is this concept of agentic RAG.
Mm.
So what's agentic RAG? It's where you, instead of the flow I described earlier, where we first retrieve the information, then we attach it to the context, and then we spit out the answer with the LLM. So in agentic RAG, what we do is we still do that, but maybe if we had a step that before, after we retrieve the documents, not we but the system, the AI system retrieve the relevant documents, the relevant, let's take the example of the course chatbot, after it retrieves the relevant transcripts, we have an LLM which is going to then compare the transcript and decides whether they are relevant to the question, to see that we didn't fetch anything not relevant. And in that way, we can then filter out non-relevant context. Because if we have garbage in, we get garbage out. If we give a lot of irrelevant information, it would make our answer not optimized. So this is one thing that the LLM can do in an agentic RAG system. Another thing that it can do is that after we retrieve the documents, let's say we filter them with the LLM, and the LLM decided to keep only the relevant documents, we generate the answer. We can then have an LLM to inspect that answer before we even return it to the user. before we return it to the user and to check if that answer actually answers the question. Okay, so this is one check that the LLM can do, and again, it's not deterministic, so that's why it's agentic. Another step we can do is that we can have an LLM not only inspect if the answer is answering the question, but to check that to verify that the answer is actually grounded in the documents that we retrieved, right? So it's not like making up stuff or whatever. So that's an example of an agentic RAG system where you're leveraging an LLM to not only generate the answer, the content, but also to make decisions in that entire process.
Can you also like help me visualize, right? Like, let's say, so if it's an agentic RAG system and you're using multiple models, one to come up with the answer, reference, and then another one to test. Like, can you give me another example on how you might actually build like an agentic RAG system, maybe of customer service bot?
So in customer service bot, in agentic RAG, this architecture I just described is actually very, very common in the industry. So if we'll take this architecture and apply it to customer service, so we can also have, for example, an LLM decide in that question. Okay, let's say we have a question that's going to that we have a bunch of data sources. Okay, so we can have an LLM in the middle choosing where to fetch that information. In that first retrieval step, we can have an LLM decide, okay, this question, you have this database where it has all the answers. If it's that question, another question, you should search out those documents and not a database.
Got you.
So the LLM is deciding where to fetch the information, for example.
Awesome. Let's go a little bit more into we talked about prompting, advanced prompting. Kind of, if you can explain what is model training and how do you train a model if you on top of the base model?
You mean fine tuning? Fine
Fine tuning.
tuning?
Yep.
So fine tune. So okay. So the data that the model was trained on, it's the entire internet. So it's a general. Usually those big models like GPT 4.0, GPT 4.5, Gemini 2.5, those are general purpose models. So what happens if I work in cybersecurity and the entire terminology and lingo in cybersecurity is very scoped, and I don't need to know anything about art. I don't need to know anything about mathematics or science. I just care about cybersecurity, about attack vectors, about how to protect my systems, etc. Right? So there is this need for this scoped to scope and to limit the information that the LLM talks about or knows. Or what if I need to actually, I have a very specific format that I want to answer, or a certain style and tone. So in fine tuning, basically, if you think of an LLM, you can think about the knowledge of the LLM as somebody who is going to, as a person who went and studied 12 years at school. Okay. And you can think about fine tuning is that you giving that person the ability to go and specialize on something, maybe go to college and have a degree in cybersecurity, for example. Not saying, by the way, the LLM doesn't know about those subjects. I'm saying that you want the LLM to be very, very specialized, right? So in order to do that, what you usually do, you have a process which is called fine tuning, is that you give your data that you want your LLM to excel in and you want your LLM to be very proficient in. And you can use managed services. All the major vendors, they do it very easily. So you simply upload your data and then what happens, they take it and they fine tune this model and make it more specialized. Now, I have to give you a big caveat that from my experience, I haven't found it useful most of the times in order to do that. So with the right prompt, you can actually achieve at least the same results. And it's much cheaper, it's more reproducible, and it's much faster. So this is just as an FYI.
That's awesome. That's great. So, in what condition where what under what condition might it make sense to train LLMs? I know for most business use cases, and I know you work with hundreds of customers for a Google, right? It's you find that prompt engineering solves like most of the problems that they're looking to do. But what are some unique cases where they might need to fine tune the model?
So I'll tell you, for example, a couple of examples that are maybe it would be beneficial. So let's say you have a certain style,
Mm,
okay, or a certain way you want the LLM to say, and
mm,
you want it to be maybe a bit, Grok is a bit, sarcastic,
mm.
and it's a bit, funny, makes a bit jokes, right? So in those kind of use case where you want a specific like tone or figure of speech, I've seen that they work okay. For example, fine tuning.
Mm. Okay, got you. So so when we're building products, right? The agentic AI RAG solution, right? There are these concept called vector databases.
Yes.
And I've had conversation with engineers, so I'm sure other product managers are also curious to know about vector databases, how they're used. So if you can kind of use this
Sure.
example of the
Yeah.
course tutor and make that concept real, that'd be awesome.
Okay, yeah. So remember when we talked about RAG? So the first part is the retrieval part, right?
Yep.
So a very common use case is to retrieve from a vector database and from a vector store, some people call it. And what is a vector store, right? So this is the question. Let's say your course transcript, right? You have a lot of transcript. You have transcript for every episode, for every video,
Mm,
and so basically the technique in order to perform that retrieval, it's not magic, right? Somebody needs to go and needs to search to find it. Who is doing it? The AI system, right?
mm,
So how does it do it? How does it do it? A very common pattern is to take your data. Okay, so to take, for example, episode number one or lecture number one,
mm,
and to index it, to save it into a vector database. Okay, and,
mm,
and, and what happens? A vector database, like the name suggests, it saves vectors. And what are vectors? Vectors are a list of numbers,
mm,
right? So you can have a one dimension vector, two dimension, three dimension if it has three numbers, but the vectors that are saved usually in vector databases are very long, very like thousands of thousands dimension.
mm,
And those vectors and the process of saving your data inside the vector store is actually also involving AI and in the model, and it's
mm,
called an embedding model.
mm,
And an embedding model simply receives it. You can think about it as a black box, which receives as input, let's say text, let's say the text of your transcript, and the output that it gives is a very long list of numbers which represent that text. Okay, so let me give you a more concrete example. You have your course, for example, on Agile, on maybe on sprints, project management, retro, right? So what if you actually go and index your transcript? So if you have one episode or one video talking, usually what you would do, you would index a part. You would take all the transcript and you won't index everything. You would index, sorry, usually what happens, we index it with parts of the data. Sorry, you can edit it later, right? So usually what happens, we index chunks of the data. We don't index everything right from the get-go. So
mm,
we would take, for example, video one transcript, we would chunk it into parts, okay, to make it more digestible. And the rule of thumb is that like the chunk that we were chunking, like how do we split from like
mm.
from one point to another, is that it should make sense when you read it. If somebody reads it and like can make sense, like what's the idea
Yeah.
and what's the main idea here, it should be okay. So we chunk it up, then we use the embedding model to turn it into a vector,
Mm,
okay, to turn it into a vector, and that we save in the vector store, okay?
mm,
And what's cool about that, once we do that, we get a very cool property of the embeddings model, which
mm,
those vectors, which represents those part of the text, I have a very cool property, and that property is the following. Let's say the property is that if you have two vectors which are near each other, okay, so you can calculate the distance between those vectors it's very mathematical. Yeah, so there is a very simple formula. You can calculate the distance. It's a metric between those two vectors, and you can say if those vectors are close or not close, right? So if and the cool property that if I find a couple of vectors that are together, there is a very high probability that they're talking about the same idea, about the same thing. So if I bring you back to reg, to reg, this retrieval part is actually taking your question. For example, what is agile, what is agile? And then if I'll go and search in the vector store to the nearest neighbors or to the nearest vectors which are relevant to what is agile, it would find me pieces of text which maybe discuss about the idea of agile and about sprints, about retrospectives, and about all that process, about Kanban, whatever. Okay, and retrieve that relevant information, right? So that's basically what our vector store is used for a lot of the time. Yeah.
Awesome. So, I would love for you to summarize, right? Like we talked about RAG, we talked about LLMs, fine-tuning, agentic AI, and even vector databases, right? How, in the context of like this course tutor, AI tutor, like kind of bring this all together. If you can kind of help summarize what are these different components and how do they come together, that'd be really helpful.
So if we'll take this example of the tutor, so you can think about us, for example, taking the transcript of the videos. By the way, most probably I generated them as well. And we can have them indexed inside a vector store. So if I'll take that example, of the AI tutor, so first of all, we'll need to take this transcript and save it into a vector store. And by the way, this transcript, probably an AI helped to generate it. So we would like to take it and to index it in that vector store, right? And in our agentic RAG systems, when the student asks a question, we can go and take that question and the AI system is going to embed it, turn that question into a list of numbers, find its relevant text that it's related to it, right? And to get information that is probably going to help us answer it. Then we would retrieve it, right? And so we would retrieve this information. We can have an LLM that would say integrate those texts that we retrieve, whether this agile answer, whether if the documents are relevant to the question that the user asked. And it can eliminate afterwards, we can eliminate afterwards those non-relevant documents. And then we can generate the answer, and another LLM is going to check if the answer is correct, if it's answering the original question, or if it's grounded in the context. And we can have a lot more of steps which are involving an LLM. So that's like everything together.
Awesome. Any last things that you want to just cover? Like, how do you get good at prompting? Maybe what's a few shot prompting? What's chain of thought prompting? How do you get good at or advance in prompting techniques?
I think we should maybe make an entire episode of an entire talk about that. But in general, and I think this rule applies for almost everything in life. If you do something a lot, you're going to get better at it, and this is including in prompting. And prompting is, when you think about it, it's not something which is hard. It's not solving a very hard math equation, right? It's actually very easy to do because you get feedback from the LLM and you can see iteratively how much you are changing the answer that the LLM answers you, right? So this technique is actually very, very iterative. And for me, working with customers, certain prompts can be written in a lot of time. So you can spend months crafting the correct prompt, which is going to give you the best answer. And this is something you also monitor and something which is changing over time. And like you mentioned earlier, zero shot, few shot, chain of thought, those are all very famous prompting techniques which people use, and we can maybe talk about it in later times. But the general rule, for example, maybe it sounds fancy, but it's very simple to understand. Let me explain in like 2 sentences. What's, for example, a few shots prompting. Few shots prompting, simply said, is an idea that once you ask your question, you give the large language model a couple of examples of how to answer that question. And once you do that, you get better results. This is in 2 sentences.
Yeah.
And if I remind you back to the beginning of the conversation where I told you that depending on the input you give it, you get different probabilities for each word. So this is what's actually happening behind the scenes. So you give it the extra examples, so you can think about it. You scope down now what the LLM is going to answer, which is going to be probably closer to what you provided.
Amazing. So, Eden, we'll definitely do a second episode where we go in the deep of the topics. One last question that I have is like, okay, how do people, aspiring product owners, product managers, people who are new in AI, how do they get good at learning AI?
This is a very good question. So I think it depends what kind of person you are. So there are people who are very autodidactive, who can search online, who can get information from here, get information from there, and the information is online. Okay, so it's online, and you have a lot of people who can learn it. That you have a lot of courses which condense everything together.
Eden, yeah. So let's talk about like, okay, you covered a lot of these topics. I know we're creating a course to go deep into these topics. Tell us how people can get good at learning this content, and also talk about the course.
So I think there is so with AI there is tons of information out there. So a lot of people are talking about it, and if you Google AI or prompt engineering, you'll get like 1,000 resources about AI. And sometimes the more resources you have, the harder it is to learn, because it really takes out of the focus. So I think for somebody who is really with no experience at all and who is very new to it, I think in general the best thing they can do is to take not just our course but any course that teaches it. Okay, because when you have a course, this is something that other people have compiled together and scoped down and made decisions of what to put in the course and what not to put in the course, and should be fitting to the correct persona, right? Because it's really a rabbit hole, right? If you the era of AI right now in 2025 and before that, it's, I like to call it the FOMO era, because you see tons tons of tweets and LinkedIn posts and AI can do this, AI can do that, and from all of that noise, it's very hard to distinguish of what is actually useful for my work and what's actually not that useful for my work. So I think like my number one tip is first, like do not go into the rabbit hole, and try to learn something in an organized way. Yeah.
Last question for you is, what are you excited about AI? What do you see happening in the next few years, and what are you scared about in like 5, 10 years?
Wow, so this is a great question, Vivek. I'm super excited about agents, about letting LLMs do things and send messages and to search things, and to actually give them kind of superpowers to really help us and to do a lot of things. And I think this is, I think the way we're seeing the market, the job market we have today, it's going to change drastically. Okay. So I think I like the saying, AI is not going to replace us, but somebody who's using AI is going to replace us. I really believe that. However, I really think there is a room a bit for concerns. I can say at least for software engineers, right? And this is what we're seeing right now. And we're seeing lots of companies with not many R&D really getting to very huge milestones, like generating hundreds of millions of annual recurring revenue, because their teams are leveraging AI for coding. Okay, and you can really see it in the coding world where you would, at least a couple of years from now, would need less programmers because AI is going to do a lot of the work. And if you add an engineer a couple of years ago, this engineer now with AI tooling like Cursor, like Windsurf, is going to output you 10x more value and more product.
Wow.
So it's like I like to comparing it like to plowing a field, and the farmers plowing the field, and then came the tractor, right? So the tractor actually took the jobs of a lot of farmers plowing the field, right? But you have somebody who is running this tractor.
Yeah.
So I think this analogy is missing one tiny bit because the number of fields you can plow is limited, right? Is limited the number of fields
Yeah.
you can plow. But the number of jobs or opportunities we have, it's growing exponentially because it's so easy now to create value with AI and to create products. So we see a lot of more companies, and those companies would need to be staffed, and they will need to have people, and they will need to have also engineers, right? So I think, yeah, a lot of people, the AI is going to do a lot of things. Like you don't navigate in your map, right? You don't have a map to navigate. You use like Google Maps or Waze, right? So this is a task that you really don't think about. So the same thing is going to be with AI. So I am very optimistic. I think it's going to shock the job market, yes, but in a good way.